Good morning, students. Chapter 7 Alternating Current Exercise continue. Exercise 7.5. You are given LC circuit having inductance L is equal to 20 millihenry and capacitance C is equal to 50 microfarad. Initial charge on capacitor Q0 is 10 millicoulomb and internal resistance of circuit is negligible. When at time t is equal to 0, switch is closed. You have to find numbers of questions. First question, that is, what is total initial energy? Total initial energy, see, Q0 is 10 millicoulomb, means initially capacitor is fully charged. Initially capacitor is fully charged. It is fully charged. Okay, initially capacitor is fully charged. So yes, you have to find what is total initial energy. Yes, simple. Initial energy V1 is equal to it is Q0 square upon 2C. Q0 10 millicoulomb, 10 into 10 is to minus 3. C 50 microfarad. You can easily find. Another question: is it conserved during LC oscillation? Yes. Yes, it is conserved. It is conserved, and we have proved it. Okay. Next question. What is natural frequency? Yes, natural frequency means omega 0. It is 1 upon under root LC. And yes, from that you can also find F0. It is 1 upon 2 by under root LC. Okay. So first A and B question, they are simple. But C and D, that you have to see. See, what is C? At what time is the energy stored? Now in question number C, you have to another question. At what time is the energy stored? First, completely electrical, then what is completely magnetic. So now we will see these two questions. Here it is. Okay, first, completely electrical means total energy is in the form of electrical energy in capacitor. So energy stored in capacitor is completely means maximum energy. Maximum energy means maximum charge. Means maximum charge. To see, here it is. To see, here it is. As initially capacitor is fully charged. Charge on capacitor at time t. Its equation is Q is equal to Q0 cos omega. Q is equal to this Q0 cos omega t. Now, what is equation of energy stored in capacitor? What is equation of energy stored in capacitor? Okay, so yes, first of all, I will write its equation. Here it is. Here it is. See, UE, energy stored in capacitor. UE is Q square upon 2C. Means it is, yes it is. Q0 square cos square omega t upon 2C. Yes or no? You can also remember this equation. If charge is maximum, charge on plates of capacitor is maximum, then energy stored in capacitor is also maximum. And this charge will become maximum. Where value of cos omega t is plus or minus 1. Why plus or minus 1? Because here it is Q square. So if cos omega t is plus or minus 1, if cos omega t is equal to plus or minus 1, Q is equal to Q0 and UE is maximum. Simple. So yes, cos omega t is equal to plus or minus 1, then Q is equal to Q0, means the charge stored on plates of capacitor is maximum and energy stored in capacitor is also maximum. So now it's max. Cos omega t is equal to plus or minus 1. When cos omega t is equal to plus or minus 1. See, if you do not know what is legal equation, then you have to put simple values. See, I don't know values of, I know actually, okay, but I'm pretending I don't know. Then see, first of all, I'm taking cos omega t is equal to 1. Now you know where cos omega t is equal to 1. What is value? So you know that cos omega t. So omega t is equal to, it is 0. Why? Because cos 0 is equal to 1. Yes, cos 0 is equal to 1. Or if I want to write fully mathematical step, then cos omega t is equal to this cos 0. Simple. So it is omega t is equal to 0. Omega means it is 2 pi upon t. T is equal to 0. So first at time t is equal to 0. And yes, we know that we completely electrical energy stored at time t is equal to 0. How to get another value? How to get another value? See, I am getting another value. Because omega t is equal to minus 1. Cos omega t is equal to minus 1. Then cos omega t. Cos pi. Yes or no? Cos 180. Cos 180 is minus 1. So therefore it is omega t is equal to pi. Now omega means it is 2 pi upon t into t. Here it is pi. So pi cut, pi cut. So here t is equal to, it is t by 2. Here t is equal to, it is t by 2. Clear? Yes or no? Yes. If you know unit circle, here students, if you know unit circle, if it is unit circle, then we know that here angle is 0. Here it is pi by 2, pi, 3 pi by 2. Here it will be 2 pi. Here it will be 5 pi by 2. Here it will be 3 pi. Here it will be 7 pi by 2. Here it will be 4 pi. Okay. So what next angle you have to consider? See, you also have to remember. Here it is. Here it is. 1, 0. 0, 1. Minus 1, 0. 0, minus 1. First, cos, sine, cos, sine, cos, sine, cosine, sine. So see, cos omega t is equal to 1 when angle is 0. Okay? Then cos omega t is equal to minus 1 when angle is pi. Now next value you have to consider 2 pi. So if here you place 2 pi, here if you place 2 pi, here if you place 2 pi, then you will get value of t, that is, yes, it is t. It is t. So yes, what is difference between these two time interval? It is t by 2. So simple. Now you have to find, get times when energy is completely electrical. When energy is completely electrical. How? At time t is equal to first 0, then t by 2. Add another t by 2 means it is 2t by 2. Yes or no? Add another t by 2 means it is 3t by 2. Add another t by 2 means it is 4t by 2, etc., etc., etc. Simple. Yes, simple. If you don't know its general equation, you can take any two first value. First value of cos 1, value of 1 it is for 0 and for it is minus 1. Clear? So yes, charge on capacitor at time t is equal to q is equal to q0 cos omega t. If cos omega t is plus or minus 1, then q is equal to q0 and u is equal to maximum. And how to find times? So at this times, energy stored in capacitor will be maximum. Now for completely magnetic, that is inductor. Now, inductor. When we know that total energy stored in inductor is maximum here, when energy stored in inductor is maximum. When energy stored in inductor is maximum. Energy stored in capacitor. Energy stored in capacitor is 0. Yes or no? Energy stored in capacitor is 0. And now energy stored in capacitor 0, it becomes UE is equal to 0 when Q is equal to 0. And Q is equal to 0 when cos omega t is equal to 0. Yes or no? So from this only one equation we can find these two cases. Okay, again, completely magnetic energy means total energy is saved in inductor. So total what is energy stored in capacitor? 0. Energy stored in capacitor is 0 when charge on capacitor is 0. When cos omega t is equal to 0. So again, cos omega t is equal to 0. Okay, so cos omega t is equal to 0. So cos omega t is equal to 0. Here what is value of cos? 1. Here value of cos is 0. For angle, pi by 2. For angle, pi by 2. So it is cos pi by 2. So yes, omega t is equal to pi by 2. Omega t means it is 2 pi upon t into t. Pi by 2, pi cut. So it is t is equal to t by 4. It is t is equal to t by 4. For another value of cos, yes, here, cos is 0. For 3 pi by 2. So I can write cos omega t is equal to cos 3 pi by 2. So again, 2 pi upon t into t is equal to 3 pi by 2. Pi cut. So t is equal to, it is 3t by 4. So now see, from this two value you can easily understand next time. Okay, at time t is equal to t by 4, 3t by 4, 5t by 4, 7t by 4, etc., etc., etc. Energy is completely magnetic. Energy is completely magnetic. Clear about this? Yes, if you don't know what is Rundle equation for cos and sine, you can put values like this. You can put values like this. Okay? Here cos omega t is equal to plus or minus 1. 1 is here for angle 0. Minus 1 is here for angle pi. From these two values, you can easily write another next times. For this, cos omega t is equal to 0. Here cos is 0 for pi by 2 angle. Here for 3 pi by 2 angle. Next, if you take 5 pi by 2, you will get 5t by 4. Simple. Clear about this? Okay. Now, next question. See, what is next question? Now next question, question D. At what times is the total energy shared equally between inductor and capacitor? See, we know that total energy U is equal to UE plus UB. But you have to find times when this total energy is equally shared between inductor and magnetic. So I am assuming when charge on capacitor is Q dash. When charge on capacitor is Q dash. Energy UE is equal to UB. Yes, I am assuming one condition. Yes or no? Yes. Okay, when charge on capacitor is maximum, energy stored on capacitor is maximum. When charge on capacitor is 0, energy in capacitor is 0. Okay, now when charge on capacitor is like Q dash, energy UE is equal to U. So therefore U is equal to UE plus UB. Okay, so therefore U is equal to UE plus UE. So therefore U is equal to 2UE. Yes or no? Yes, it is. Total energy always remains constant and it is Q0 square upon 2C. But when energy is equally shared, I have assumed charge is Q dash. So it is 2Q dash square upon 2C. Clear? So this 2C cut. So therefore Q dash square is equal to Q0 square by 2. And therefore Q dash is equal to Q0 upon 2. So when charge on plate of capacitor, Q dash is equal to Q0 upon root 2. Energy is equally shared on capacitor and inductor. And this result you have to remember. Now, equation of charge, that is Q is equal to Q0 cos omega t. Q is equal to Q0 cos omega t. Okay, now I have to put value of Q. Phase 1. What is charge on capacitor when energy equally shared? Q dash. That is Q0 upon. Yes, here I can write it is Q dash. Is equal to, it is Q0 cos omega t. So therefore cos omega t is equal to 1 upon 2. So now what is conclusion? whenever cos omega t is equal to 1 upon root 2, at that time Q dash is equal to mu 0 upon root 2, at that time energy is equally shared. Now again, how to find times? I will take another values. See here, cos omega t 1 upon root 2 means it is cos pi by 4. Yes or no? Cos 45. So yes, omega means 2 pi upon t into t. It is pi by 4. Pi cut. So t is equal to, it is t by 8. At time t is equal to t by 8. Another value, cos omega t is equal to, it is cos 3 pi by 4. Yes, when angle is 135 degree. Again, value of cos is minus 1 upon root 2. So 2 pi upon t into t is 3 pi by 4. Pi cut. So t is equal to, it is 3t by 8. It is 3t by 8. So now from these values you can find times when time t is equal to t by 8, 3t by 8, 5t by 8, etc., etc., etc. Charge on capacitor is Q0 upon root 2 and energy is equally shared between inductor and capacitor. Clear about this? Clear about this? Okay. Now what is next question? See. Now next question. If a resistor is inserted in the circuit, how much energy is dissipated as heat? In resistor, maximum energy is dissipated. Maximum energy is dissipated. Maximum energy is dissipated. So therefore, total energy, that total initial energy we have found in question number 1, that total energy is dissipated as energy. The total energy, that is UI, is dissipated as heat. So yes, it is one single question, exercise 7.12. And yes, it is one important question. You have to remember this result particularly. Clear? So yes, for today, this is it. Chapter 7, alternating current. Next question from exercise 7.25. And last one from this chapter. See, here it is. One town, a small town, has demand of 800 kilowatt power at 220 volt. It is supplied from power station, which is 15 kilometers away, having producing electrical power at 440 volt. The resistance of 2 wire line is 0.5 ohm per kilometer. The town gets power from line through 4000 to 220 volt step down transformer. Numbers of questions are there. First, what is line power loss? Second, supply power. Third, characteristics of step up transformer. See, first of all, I will draw the diagram. See, there it is. It is power station, for example. It is power station. At power station, see, this 440 volt. Okay, 440 volt electricity is produced. Electrical power is produced. Then, yes, we know that the electrical power which is produced from power station, first of all, we have to increase this voltage with the help of step up transformer. Okay. Then it is supplied to town with two wire line like this. For example, two wire line. Okay. And yes, it is two wire line. Clear about this? Now, yes, the town gets power from line through 4000 to 220 volt step down transformer. So again, here it is step down transformer. Here it is step down transformer. Step down transformer. Okay, step down transformer. Its characteristics is 4000 to 220. Means here, from power station, electrical power is produced at voltage 440. This step up transformer will increase its potential. Then it is moving. At this point, its potential will be 4000 volt. And the step down transformer will convert it into 220 volt, which is requirement of, which is demand of town. Okay, at power it is town. Okay, 800 kilowatt. 800 kilowatt. Clear? So yes, it is diagram. It is diagram. Clear about this diagram? Clear about this diagram? Okay, now we have to find numbers of question. First of all, what is line power loss? Then what is supply power? Okay, so first of all, we will find resistance of two wire line. Resistance of two wire line. R is equal to, see, resistance of two wire line means you are given two wires into is 0.5 ohm per kilometer, means if 1 kilometer wire is there, resistance is 0.5. Resistance is 0.5. Here you are given 15 kilometer away. Power plant is 15 kilometer away from town. So obviously what is length of wire? 15. So it is 15 into 0.5. 0.5. Now 0.5 means it is nothing but 1 by 2. So it is 2 and 1 by 2 curve. So it is 15 ohm. So yes, it is 15 ohm. Clear about this? So yes, R is equal to, it is 15 ohm. Okay. Now first of all, as I have to find line power loss. Line power loss. So I will find what is current flowing from line. Current from line. Current from line. How to find current from line? How to find current from line? See, here it is. See, here it is. From this town gets power of 800 kilowatt. This town gets power of 800 kilowatt. At this step down transformer, what is voltage? It is 4000 volt. It is 4000 volt. So with the help of equation P is equal to VI, if I want to find I, then it is P upon P. What is P? It is 800 into 10 raised to 3. And yes, at this point it is 4000. Why 4000 I have considered, not 20? Because we have to find current from line. Current from line. Current from line. And at this point, its potential is 4000. That's why I have to consider this. Okay. So yes, 3030 cut. Here it is 4 into 2 means it is 200. So it is 200 ampere. So current flowing from line is I is equal to, it is 200 ampere. Now loss, line power loss. Now line power loss. Line power loss. P is equal to, it is I square R. I square 200 square. And what is value of resistance? Yes, it is 15. Yes, it is 15. So it is 200 square means it is 2 square means it is 4. Yes or no? Yes. Into it is 10 raised to 4 into 15. 15 into 4. 15 into 4, it is 60. So it is 60 into 10 raised to 4. Or I can say it is 600 into 10 raised to 3 watt. Or I can say it is 600 kilowatt. It is 600 kilowatt. So what is line power loss? Okay, when this step up transformer increases voltage and then it is supplied via this two wire line. In this wire line, what is loss of power? 600 kilowatt. 600 kilowatt. Next question is supply power. So yes, from this, how to find supply power? How to find supply power? So it is easy to find supply power. What is demand actually? 800 kilowatt. 800 kilowatt. What is demand actually? It is 800 kilowatt. Okay. So if demand is 800 and I supply electrical power at 800, then what happens? This two wire line 600 kilowatt. 600 kilowatt is wasted. So here it will be only 200 kilowatt. So if I have demand of 800 kilowatt, so I have to consider what is power loss in this line. What is power loss in this line? Okay, power loss in this line is 600. Demand is 800. So total power supply P is equal to, it is 800 plus 600. It is 1400 kilowatt. Then and then, if 1400 kilowatt power is supplied, then 600 is used or it is wasted as heat energy, and remaining 800 kilowatt is used in town. Clear? So it is second question. Now third one. Okay, what is characteristics of step-up transformer? Now characteristics means what? See, step-down transformer, its characteristics is 4000 to 220, means it decreases potential from 4000 to 220, voltage from 4000 to 220. So what is characteristics of step-up transformer? Yes, input is 440. So what is output? What is output? Again, voltage drop due to resistance. V is equal to IR in this line. V is equal to IR in this line. What is I? 200. What is R? 15. So it is 3000 volts. So it means when power is supplied from the step-up transformer to the step-down transformer, 3000 volt decreases. 3000 volt decreases. So yes, at this point it will have 7000 volt, obviously, because if it has 7000 volt and 3000 volt decreases, then and then here it will be 4000 volt. So therefore characteristics of step-up transformer, it is 440 volt to 7000 volt. It is 440 volt to 7000 volt. Clear about this? So yes, it is one question which is based on transformer. Now next question is exercise 7.26. Exercise 7.26. Okay, all data is same. Just this step-down transformer. This step-down transformer is changed from 40,000 to 220 volt. Yes, this 4000 is replaced by 40,000, means high voltage line, Then yes, you have to calculate this all data again. You have to calculate this all data again, and you have to compare answers. Yes, this answer you will get small. Okay, power loss in line, we can decrease at high voltage. Clear about this? So yes, these are two last questions from this chapter number 7. For today, this is it.